This is problem 5.6.4. We observe independent flips of a fair coin until head occurs twice. X1 equal the number of flips up to including the first head, and X2 is the number of additional flips until we observe the second head. What are the PMF of the X1 and the probability of X2? And the second question is that these two random variables are independent or not, and find the joint PMF of X2 and X1. So we can solve this problem for the general case when the probability of head is P. So we can say here, because it's a fair coin, and so the probability of P that we can observe the head is half. Viewing each flip as a Bernoulli trial in which head is a success means in this experiment, so the number of flips until heads is the number of trials that we need to observe the first success, which has a geometric PMF. We need to repeat the experiment until we observe the first head. That is the success, our goal. So X1 has a geometric distribution, and we know that the PMF of a geometric distribution is equal to 1 minus P power X1 minus 1. We have the failure result, and at the end trial we have success, that its probability is equal P. That X can be 1, sorry, this is X, not X1. For X equal 1, 2, and etc. Otherwise, it can be 0. Similarly, no matter how large X1 may be, the number of additional flips that we can observe the second heads is the same experiment as the number of flips needed for the first occurrence of head. So we can say again that X2 has a geometric distribution, and its PDF it's the same as the X1. So furthermore, the flips needed to generate the second occurrence of heads are independent of the flips that yield the first heads. So we can say that X1 and X2 are independent, and we can say the probability, the joint probability, we know that for two independent variables, we can say their joint PMF is equal to multiplication of the marginal probability. And we want to say what is the probability of X1. I can say 1 minus P power X1 minus 1 times P. And for the probability of X2, we can write again, but here instead of X1, we have X2 minus P. So I can rewrite to X1 plus X2 minus 2 times P power 2. For X1 equal 1, 2, etc. and X2 1, 2, etc. And for other value of the X1 and X2, it's equal 0. If it's a little bit, for example, vague for you that you cannot understand, we can rewrite as well that we have, for example, imagine we have the first trial is not a head, is tail until we repeat to observe the first head. This is x1 minus 1 and total is x1. Again, we need to repeat our experiment until x2 minus 1 until we observe the second head. So as you can see, if you want to write, we have x1 minus 1 plus x2 minus 1. We have the failure result, and we have two success, that the probability is p power 2. So you can see that they are independent from each other.